My name is Brandon Cody, and this is my video for Lab Module 3. This is the DC motor experiment, and I'm trying to turn this motor on and off using a button. Here's my setup. Here's my code. Up top, we're setting some integers. We're setting the initial state of the motor at 0. We're saying the motor's off. We're also setting the previous and current states of the button so we can remember its position. We're also defining which pins of the Arduino are connected to which inputs on the controller and also the button. In the setup, we're saying that the inputs on the controller are outputs on the Arduino. We're also setting the button pin, or pin 4, as an input on the Arduino. In the loop, we have an if statement inside an if statement. It's saying that if the previous state of the button is 0 and the current state of the button is 1, or if the button was pressed, then the motor should be turned on if it was originally off. Otherwise, it should be turned off if it was originally on. And then we want to remember where the new position of our button is, so we define that new position as the previous position. And we're also setting a 100 millisecond delay in between each loop. Now we can go over here and see that the code does work. Turns the motor on and off. Thank you. In this video, I will show that I can change the direction of the DC motor using the button. Here's the code I'll be using, and the only difference between this code and the code that I use to turn the motor on and off is that this right here says high instead of low. If we go over here, you can see that pressing the button does change the direction of the motor. Thank you. This is my video for running the motor in a sequence. Here over at the code, the only difference in the initial setup is that we've added a speed control pin. And in the setup, we've called that speed control pin an output. And we've also set the initial rotation direction of the motor. In the void loop, we're still saying that if the previous state of the button is 0 and the current state of the button is 1, or if the button is pressed, then it can run these tasks. I have it running the motor counterclockwise at quarter speed for a second, running it clockwise at half speed for a second, and then running it counterclockwise at full speed for a second. And then at the end, we set the new state of the button as the old state, so when we press the button, it will run again. Let's watch. There it is, working. Thank you. This is my video for the stepper motor experiment. I used the 28BYJ48 stepper motor with the ULN 2003 stepper motor driver. This stepper motor has a total of 2,048 steps per rotation. Here's my code, which I got the majority of from the course website. Up here, we are just defining the stepper motor pins to Arduino pins and saying that the initial step number on the stepper motor is 0. We are then saying that these stepper motor pins are outputs. In the loop, there are 4 for statements, each of which rotate the motor a certain amount of steps and in a certain direction. This line here, for example, rotates the motor 1,048 steps counterclockwise, which is equal to 180 degrees clockwise for this motor. There is a 2 millisecond delay in between steps, which is equivalent to 1 rotation every 4.096 seconds, or 14.65 RPM. This next line will rotate the motor 180 degrees clockwise back to the reference position. Then we have this line of code here, which will rotate the motor 3,072 steps, or 540 degrees counterclockwise. And the last for statement will rotate the motor back to the initial reference position, or 540 degrees clockwise. Down here is a large if statement with quite a few switch case statements inside of it. This statement its purpose is to control the steps of the motor. And now let's go over and see it working. So I'll run the code. 180 degrees, back. .540. And back. Looks like the tape came a little loose there, but the code is working. It is spinning the stepper motor 180 degrees and then 540 degrees. Thank you.